Yeah, we go ahead and this is a SCR, power semiconductor device. First one, we'll look about the power semiconductor device. So what are the power semiconductor device? So these are the power semiconductor device. Thyristor, GTO, IGBT, MOSFET. These are the power semiconductor devices. Okay. So what is the purpose of this device? Turn on and turn off. That is a major purpose. Turn on and turn off. There is a two purpose. Okay. Then what is the difference between one device to another device? That is important. That is about the power semiconductor device play a major role. So particularly you have look about the thyristor. It is a semi-controlled device. There it is called as a semi-controlled device. Why it is a semi-controlled device? Semi-controlled device means it's a controlled turn on, uncontrolled turn off. Uncontrolled turn off. So turn off is not possible. Turn off the device is not possible. Not possible means okay, through the gate terminal it is allowed to you can't to turn off. Okay, then we'll coming back to that this device later. What is the thyristor? It's a semi-controlled. Semi-controlled means what? Semi means what? Off. So controlled on and uncontrolled off. Uncontrolled off. Off is not in our control. Then second one is a developed device GTO. So GTO also the same thyristor family. It is a developed device GTO. The thyristor is another name is called SCR. Another name of the thyristor is SCR. Then next one device is a GTO. So gate turn off thyristor. Gate turn off thyristor means what? So controlled on and controlled off is a possible. So it is also thyristor family. This is a SCR. This is GTO. What is the relation between these two? You have look at this is a symbol of that one is given. First one is given about the diode. It is a unidirectional flow. So anode to cathode. It is only one direction is a power flow devices, current control devices. Only one direction it is a flow. Okay. It is a control the currents in only one direction. See that one current is a flow this direction. It is not flow opposite. Cathode to anode. It is not flow. It will going to not operate it. So it is a operate on that unidirectional forward bias only. The same okay model is developed about SCR as well as GTU. Then what is the difference between these two? So if I have look at here is a gate terminal available. So gate is a present compared with the diode. Diode is a gateless SCR you can say, or it is an uncontrolled device, uncontrolled on, uncontrolled off. But what about this one controlled on? Controlled on through the gate you will going to on the device. So here you have look at this is GTO. The arrow mark you can see inward as well as outward. So it is the two arrow mark. So that's why control on and controlled off is possible. That's all. Control on, control off. Next we will going to go ahead further. Okay. So how to turn on the device? For example, anode is available, cathode is available. Okay. Then you will going to give that one power supply. So power is a normally plus is you need to do. So power supply plus with respect to minus. Okay. Then I need to operate for that one lamp load. Okay. Yes, lamp is connected and connected to the source. This is a lamp. And close the circuit. Yes, it is a close it. So this is a power circuit. This area is called a power circuit area. Okay, when this lamp is a glow, when the switch is on, then only the current is a flow. If the current is a flow, then the lamp is glow. That's all. Then only the lamp is a glow. Okay. So when current is on, so when current is a flow, when current is a flow, the switch is closed. When the switch is closed, you need to trigger the gate terminal triggering. So you need to trigger. How to trigger? So you will going to trigger. There is a method is there. What are the method? Resistance triggering, R triggering, or RC triggering, or UJT triggering. So you will going to use one resistance. Yes, resistance you will going to use and give the power supply. Where is that one cathode is here? So here is you going to so plus with respect to minus. So you will going to give then close the circuits. So if you are going to give then what will happen? So this through this power supply or the resistance. So either this resistance you can vary or power supply is vary or both also you can vary and give the current to the device. What is the current you need to give? So the current is needed, minimum needed current is 3.54 milliampere. 3.54 milliampere once you will going to apply, what will happen? The switch is closed. Once the switch is closed, the power circuit is working. The power circuit is working. Okay. Once, what is the beauty about that one? See, what is the beauty of this SCR? You have no it is interesting about that one. What is interesting? See, once you will going to apply 3.54 milliamp through one ammeter you are connected, then you will going to check it about that one. 3.54 milliamps once apply, the switch is on. Okay, once switch is on, okay, once the switch is on, after that what you will going to do? You remove this circuit total. What is this circuit? Is called a triggering circuit. This triggering circuit you will going to remove, disconnect it. Power you will going to off the power. Even you will going to power off the lamp, it will going to keep on glowing. Why? Means the power circuit is never it will going to turn off. See, that's why the power circuit is never turn off. So that's why it is uncontrolled turn off. Then how to turn off the SCR? Then how to turn off the SCR? See that one. Okay, even you will go to triggering circuit, you will go to remove, you will go to off the triggering circuit, but the lamp is never turn off. Why? Why that lamp is not turned off? Because switch is closed. The switch is closed. The switch is on. Then if you will go to off the switch, then only you will go to stop to flow this current. How to off? That is it. Here you will go to what is the power supply you are applied? DC power supply. If you are going to apply the AC power supply, means what will happen? If you are going to apply the AC power supply, if you are going to apply natural commutation is possible. What is the natural commutation? Positive magnitude. After that, automatically come to the zero. So during the zero time, it will go to turn off. So natural commutation is possible, but due to now natural commutation is not possible. Why? Because it's a DC power supply, unidirectional, it's a flow. So natural commutation or another name is line commutation is not possible. Then what you want to do? You can go for the forced commutation. Forced commutation. That's why commutation method is class A. Here also A, B, C, D, E method available. In your syllabus, C and D. In your syllabus, C and D is there. So this is a commutation of the circuits. Why do you want to go for commutation? For turn of the SCR. What is the method? So class A, B available, C, D. What is the CD method means? In the circuit, accelerate device is used. One more SCR is they will going to use. That one more SCR as well as elements of the inductance and the diode it is helps to turn off the main SCR. That's why this is a commutation circuit. That's all. Then what is the method we are triggered? R method only. I have drawn in the circuit is R method. Similarly, R and C you can use. That is called the RC method. Or UJT is the best one. You will go for the UJT triggering method. Why UJT is best one? You know, what is the meaning? Sorry, why UJT is best means the drawback of R and C. This two R and RC method is a more power loss device. More power consumption as well as power loss. It is a waste of the energy. That one you will going to eliminate it with the help of the UJT method. UJT is a very best about that one. It has also 3 terminals, but you need for that one in the output terminals. So like about the device, it will going to develop. So here is that. So this is a here. What is that one? E, yes, E, B1, B2. So in that one power supply, you will going to apply to here. Yes, you will going to apply the power supply in the time in the side. So potential transformer is needed. That's all. One potential transformer is used. Normally, if I have look about the practical application, the BJT method only they will going to use potential transformer method. It is used to they will going to develop about that transformer method, gate and cathode. Like they will going to develop and they will going to connect. So power losses it is will going to save the power loss. Okay. Then rating. So far we have discussed about the rating. What is the rating? Yes, let's we can go ahead further. So you have see that one it's steps like high power device is a SCR or thyristor you can say. Then second one is a GTO. Then third one is a lowest. Next low for the power is a IGBT. Then very lowest power is a MOSFET. MOSFET is a low power device. What is the power? 1 kV. I mean, it is a thousand range only, but it is a high frequency device. What about that SCR? SCR is a see that one mega, so 10 power. Okay, even 10 mega it is a possibilities. But the SCR is a low frequency, high power, low frequency. MOSFET is a high frequency, low power. That is a difference. But this is somewhat medium. So good about the frequency. You have to see that one 10 kilo it's suitable as well as the power also 100K. So that's why most of the inverter application you have seen now everywhere it's IGBT is used. chopper application, inverter type of application, everywhere they are using on that one. Then where it is SCR is used today, SCR is using for rectifier application as well as a transmission line. So transmission line, it's high power devices is needed. So SCR is used there. SCR or GTO, they will going to use. Okay, but this too is a unidirectional only. Okay, so this is about we have discussed about the ratings or the specification about that one. The next one we go ahead about the static and the dynamic characteristics. Static characteristics, so far we have discussed about the one drawing the diagrams. The drawing the diagram of the triggering circuit. Another one is a power circuit. That is about the static characteristics. Okay. Further, what we are going to see about the static characteristics? Yes, I will going to show you for easy to you are going to once again understand about the static characteristics. Yes, this is static. So what I have drawn, that is the things. In previously that SCR is reversely there. So now it is a top is a anode, bottom is cathode is there. Okay, so this is it is a triggering circuit. This side is a power circuits. So this is about the static characteristics. What is the purpose of static characteristics? For testing the device. And further, you will go ahead on that one the output of the current. What is output of the current? Anode current. Anode current as well as here anode to cathode voltage. So you will going to draw the curve between the anode current and then IA versus the VAK. IA versus the VAK. You will going to draw the curve. So you have look at this is a curve about that one. This curve is very important. This is called as a static characteristics curve. In the curve, when you are going to look at, so this is a three different method of the triggering. So without apply the triggering, the SCR is never turn on. 3.54, excuse me, 3.54 is a minimum milliampere is a minimum current is required to turn. Okay, so let's you will apply for that 3.54 milliamperes. You will going to apply for that 3.54 milliamperes. If you are going to apply 3.54 milliamperes, means what it will happen? See that one here is anode current available, here is current available, output current, here is the output voltage. That means VAK voltage is available. The curve is start to move from slowly increase. Current is a very slow minute current. Voltage is increase. Voltage value only increase. So once cross the breakover voltage, what will happen? The current value suddenly start to rise. So below the current, below the value, okay, below this value, this is a curve. Below this is a point. If I have draw the curve, so this is a point. In the below the point, this point is called a holding current. So in the point, you can say about that one. This is called the latching current. Holding current, latching current. What is a holding current? Holding current is the turn off the point. See, once the breakover voltage is crossed, the SCR is start to trigger. I mean the switch is closed. That's all. Once the breakover voltage is crossed, the SCR the switch is closed. Once the voltage, once switch is closed, okay, here is there. Okay, the switch is closed. If switch is closed means across the voltmeter, what is the value? The voltmeter across the value is 0. That's all. The voltmeter across the value is 0 only. So that's why it will going to come to the characteristics come to the 0 when near to that one. The current value only increase. The output current or anode current is only increase. That is called a forward conduction. Once cross the breakover voltage, the SCR is conducted. So below the breakover voltage, SCR is conducted? No, SCR is not conducted. Voltage is increased, current is also increased. What about the current? Leakage current. The current is called a leakage current, small current, microamps. This the current is a microamps. This a period is a microamps period. See, this is a period. Where is a period? This period of that one is a microamps. So that's why the current also increase, output voltage also increase. Once cross the breakover voltage, the SCR is start to conduct. So below the breakover voltage, if you have draw the curve, this is a below the breakover voltage, it is called holding current. So below the breakover voltage is a holding current. That means a minimum current below which the SCR it will going to turn off. When the current is this is a current, okay, this is a current. This is a point. In the point, if the current is go above, that is called the latching current. Minimum current is required to turn on the SCR, that is called latching current. Minimum current below that one SCR is go, The minimum current is it will go to below which SCR is below. It will go. That is the turn of the SCR. Turn of the SCR. Okay, this is the turn of the SCR. Okay, so this is a method about the forward blocking. Forward blocking, the leakage both also linearly increase. Both also linearly increase. What about the current? Microamps. Microamps current. Okay, breakover voltage. Okay, so for example, I said about the 3.54. When you are going to apply 3.54, this is a breakover voltage very nicely. You're going to say, suppose I will going to apply for the 10 milliamperes. Without the variation, your curve is going to go like, you can't to see the variations. You can't to see the variations. In practically, you are also doing that experiments. If you want to see this curve, then you want to apply for that one 3.54. Okay, fine, good. So triggering method means resistance triggering, potential divider method, resistance they are used on that one. They will going to trigger the power supply. Or RC method. Okay, here is that. So power supply R and C is connected and they will do the triggering. But one more advantage about RC method means you will go to variations. It is a possibilities. Variation is possible. 0 to 180-degree variation is alpha variation is possible. And the UJT triggering method, yes, you will going to look about the UJT triggering method. So this is about that one UJT type of the triggering method. You will going to do to that SCR. See their power supply, and then here RC as well. Here is they will going to do to the E terminal, and this B1 is connected to the power supply, and here is you will going to do that one. Actually, the resistance is showing for understanding purpose, but a potential divider they will going to use potential divided transformer. UJT triggering method practically they will going to use. Okay, that's all. So commutation method means there is a 5 method available. So universal class C and class D is there. That is means auxiliary SCR used to turn off the main SCR. What is the class A, class D means? So here you will going to see, look at, okay. This is the commutating elements, even inductance and capacitance. It is connected series with the load means it is connected series with the load. Even it is also series with the load, but particularly this L and C is connected across to the switch. Across to the switch. If it is across to the switch means that is a class A. If it is only connected series with the C here, okay, series with the load. L and C is connected series with the load. Okay, load resistance and seriously connected. If it is seriously connected, means that is a class A. Either the L and C element is connected series with the load, or that is if it is seriously connected with the load means that is called class A. If it is connected across to the switch means that is called class B. That's all. So you just know about what is the L and what about commutating elements. So this is a commutating element. Come to the class C and the class D method. What is the class C and the class D method? You have see that one. This is about that one power circuit. Okay. And this is the main SCR, load resistance. Yes, this is the power circuit. And this is a 3 more element is used. What are the 3 more element? RC and then one more SCR that is called auxiliary SCR they are using. What is the purpose for turn of this SCR? For turn of the SCR, once I will going to remove the power supply and through already it will going to charge the capacitance. This charge capacitance initially it will going to charge in one directions. When you will going to remove the power supply, it will going to start to flow from the reverse across to that one. So through that one reverse across to that across to the SCR, it will going to turn off. So this is about the auxiliary method to turn off the SCR. Similarly, class D also same. Class D also, what is that one? When you will going to power is applied during the time it will going to trigger. I want to turn off that condition. What will happen? I want to turn off the SCR. So power I need to turn off. Power I need to disconnect it. Okay, initially it will going to charge the power supply. Now it will going to plus with respect to the minus. So when this switch is need to close. Once it is the switches need to close means plus with respect to minus. So initially top is a plus with respect to minus charging. Okay, once I want to start to discharge means see that one I will going to do that one opposite direction. If it is a power is a flow opposite direction, it is called a reverse bias. So reverse bias I will going to apply to turn off the device. That is about the turn off the methods. Turn off the methods. So here also same as it is. As usual, once I will going to remove the power supply is removed. Okay, then I want to close this circuit. So I want to apply for that one reverse power supply plus with respect to minus. So you know that one, it is a flow this direction. So it is, I need to flow opposite direction. Okay. So the switch is closed. So through the closed switch is closed to, I will going to give the power supply on that one plus with respect to minus. How? With the help of the capacitors, I will going to give that one. So to turn off. So this is called auxiliary method. Based on that one, you will going to do the triggering everything on that one. Okay. So let's we go ahead on the remaining points. Construction. Yeah. So purpose. So purpose also will touch about the purpose. You know, this is ACR is connected and then power supply is applied and then connected series with this load. So it will going to, you know, it is only unidirectional power flow. So only one direction, forward bias only operated. So when this is a AC power supply, AC power supply means phase with respect to neutral, positive off cycle. So during the positive off cycle, what will happen? Okay, the current is a flow, start to flow from this one and then close that one. So circuit is a flow closed. If circuit is closed, it means okay, whatever the source, the same source is coming to that load. Source is a 50 voltage. The source is a 50 voltage means the 50 voltage is coming to the load. So load also 50 voltage. Positive off cycle only I am teaching you. So positive off cycle, let's see that one. It is a 50 voltage. So 50 voltage coming to that one. Same 50 voltage is coming to the load. Positive off cycles. So here you will going to vary the resistance base, either start from the 0 or it will go to 0 after 30 degree, you will going to decide. So here you will going to use for the triggering circuit resistance method and give the power supply plus, and with respect to minus, minus is a cathode. That is a triggering circuit. It is helps. Okay, positive off cycle is okay. So whatever the same 50 voltage coming to the load. What about the positive off cycle is over? Next one is in AC power supply. So phase with respect to neutral. The next one, neutral with respect to phase. Neutral next with respect to the phase. So now it is a second half. During the second half time, so power is a flow from here because phase. So this is bottom is a phase. Bottom is a phase with respect to neutral. So it's this second half cycle. Okay, input is second half. Then it is a start to flow from that one load. It is a flow, but here stop. The switch is not operate on the reverse bias condition. So open only. So that's why the output is 0. That's why the output is 0. So the if I have seen that one, this that's why this diagram as well as this waveform is off wave rectifier, controlled rectifier. Important. Controlled rectifier. Why it is called controlled rectifier means SCR is used. Fine. So yes, let's we go ahead on with the construction. Yeah, construction point of view, see that one, it's a 3 terminal of that one symbol, anode, cathode, gate terminal. So P N P N. So how many layer, how many junction is used? You want to see. See here, we will going to look it. So P N P N. So how many layers and how many junction? So 1 junction, 2 junction, 3 junctions. So 3 junction. So junction 1, junction 2, junction 3. You will going to write 1, 2, 3. You will going to write. What are the layer? P N P N. 4 layer. What are the layer? P N P N. So okay, P for the anode, N for cathode, another P for the gate terminals. Another P for the center P is for the gate terminals. Okay, then you will going to look it. Yes. So how this PNPN is how is PNPN is developed? How developed means 2 transistor. So 2 transistor is analogy. That is called analogy. PNP and NPN. 2 transistor is connected. Okay, and one more circuit. See that one. This is a connection of inside. So they are connected and developed about SCR. Ready-made SCR is developed. Ready-made SCR is developed. This a ready-made SCR is available. What is there inside means analogic construction of the 2 transistor. Analogic construction of the 2 transistor is developed. See, output is what are the 3 terminal? Only 3 terminal: cathode, anode, and gate. So refer the data sheet, and then you will going to find out which one is gate, which one is cathode, and which one is anode. Gate, anode, cathode. Like you will going to find out. Okay. Yeah. So inside, when you are going to go look it inside, it is a 2 transistor analogy. So analogy for about that one. Okay, they will going to connect it. Okay. You mean the first one is a base, base is second one is output is connected, then second one is a base, the first one is out, I mean collector terminal is connected, collector terminal is output terminal. So like it is connected. Okay, so if it is connected means that is called analogy about the construction point of view. So this is over about the construction. So we are discussing about the construction, static, specification and rating, triggering purpose of the triggering and the commutation element. And then we're going to look about the next dynamic characteristics. Dynamic characteristics is very simple. It is a turn on only, control turn on. Turn off is uncontrolled device. Turn off is uncontrolled device. So I already said about that one. Dynamic characteristics means easy to understand. You just look at these pictures. So here is a various animal is there. So what this animal is doing, where it is look, what it is doing, just you will want to see the picture, start to write the answer. See the pictures. So you will going to say, start to write about the answers. So for example, so this one is a turn on the right hand side and looking on towards on the ground. So just you will going to say the animals. Okay, and then line is simply sitting on that ones. Okay, so like about you will going to say see the picture and then start to say. The same method is coming to the dynamic characteristics. Look about that output of the voltage and output of the current. So look about that output of the voltage and output of the current. Okay, this is a input current, is a gate current, and then this is the output of the voltage VA. So what about the VA conditions? And then output of the current. What about output of the current? This output of the current and the output of the voltage. So you will going to say about the on conditions. The on condition it is included for the delay time, rise time, and the peak time. Three combination is included: delay time, rise time, peak time. Just what this animal is, a particularly elephant is, what it is doing. So it is standing and it will going to stand on that one. Similarly, you are going to say the delay time. What is the delay time? This is a delay time during the output current. Delay time is output current is start to rise from the leakage current to the 0.1 of the IA. During the delay time period, is a delay time period. The leakage current is a rise from that one minimum leakage current. Sorry, output current is rise from leakage current to the 0.1. And what about that one voltage? So during that one output voltage, okay, it is a VA peak value to that one start to decrease. So start to decrease into the 0.1, so 0.9 VA. So you know that one once the switch is closed, the VA is equal to 0. The VA is equal to 0. When once the switch is open, the VA value is high. So the switch value is open, the VA value is high. Okay, once the switch is closed, the VA is equal to 0. So you see that one, this is a point of the closed. During the condition, what about that one? It is coming to the near to the 0. That's all. Except the leakage current, leakage voltage drop across the diode. Okay, except that one, it is coming to the 0. Okay, so during the delay time means see it is rising and that is a decreasing. The next one, rise time. Rise time, it is moved from the 0.1 to the 0.9. It is a move from the 0.1 to 0.9, everyone, right? And then it is start to decrease from the 0.9 to the 0.1, 0.9 to 0.1. Just opposite. Then next one is a peak time, 0.9 to the settled. 0.9 to the settled. Yes, settled. What about here? 0.1 to the minimum voltage drop across to the diode. I mean near to the 0. 0.1. There is a 0.1, then 0. That's all. Okay. Then this is about the on time. On time is a combination of delay time, rise time, and the peak time. So draw the figure and then start to say about the answer. Then commutation. I mean, turn off the method is you will going to use for the commutation. What is the method? Commutation class A, class B, class C, class D method you will going to use. What is the class C and the class D? Auxiliary commutations. So this is called the reverse recovery time and then gate recovery time. These two it is helps to you will want to turn off the time period it is showing. Okay, so relay, okay, reverse recovery time, gate recovery time. So what is the reverse recovery time? You have reverse recovery time, so it is goes the output current below the 0 and coming to that one is a point which. What about that output voltage? It output voltage it will going to maintain initially on that one 0, and after that it will start to move further to below 0. Why? Because you will want to apply the commutation. What is the commutation? Reverse capacitance voltage. I said about the reverse capacitance voltage is applied across to the SCR. Yes. Then totally it will going to come to the 0. That's all. That is a gate recovery. So that's all about that one, the dynamic characteristics. And yes, what else it is remaining? Yeah, production of that one, it is very important about the production. So you will going to save your SCR. What is the method? Either over voltage or over current or thermal production. Thermal production means heat. So that's why heat sink is available. That is the device. So in that back base, the base, it is, they will going to connect it to the heat sink aluminum. Then you will going to connect it through that heat sink paste, and it's a mica sheet. Okay, with the help of the mica sheet and then heat sink. So it will going to absorb the heat. It will going to totally, it will going to I mean, reduce the heat, thermal heat. Okay, that is a heat sink. Okay, the next one, what is another one is, yeah, over voltage and over current is produced. Certainly, over current due to the stress. So, multi-level inverter we are studied recently. In the multi-level inverter, okay, multi-level inverter. The purpose of the multi-level inverter is reduce the voltage stress. Reduce the voltage stress. Compare with the conventional inverter. Conventional inverter voltage stress is more. Why voltage stress is more means because the switches is there, the switches is on and off continuously, on and off. So due to that sudden on and off of the conditions, over voltage and over current is produced. So that one we want to. That's why voltage stress is happen. Continuous stress heat is produced. Then it will going to reduce fail to that equipment. Then you will going to protect that one soft switching technique. Soft switching technique, or you can use here also same. Here is inductance used to, you will going to protect the over current. Over voltage you will going to snubber circuit used to, you will going to protect it. Over voltage snubber circuit used to, you will going to protect the your ACR. See that one SCR power circuit. So power circuit, anode is there, cathode is there, connected with one inductance. So di by dt production you will going to change. So automatically you will going to flow of the current is you will going to minimize the flow of the current. High current is will minimize. So particularly I already said about this one sample example. Agriculture land side, when you have look about that one, there is a 10 house. Okay, there are 10 agriculture peoples or customers. They are getting the power from only one transformer. I will draw the diagram. So this is a power, this is a transformer. There is a 10 customers available. Okay, 10 customers. This 10 customers, okay, three-phase power line. So 1, 2, 3 line, three-phase power line. The three-phase power line, they will going to, okay, they will going to get the power from this transformer. Okay, the power is a flow. So all members, they will going to in the line, they will going to connect it to that one. They will going to connect it. So all members, they will going to connect it to. They will going to extract the power from the line. So this is customer number 1. This is customer number 10. But whenever you are going to look about the customer number 1, they are used for in-condition lamp for testing purpose. That bulb, they will going to get the failure every time. They will going to get the failure of the power bulb. It will going to burst and it will going to burn on that one every time. Why means high current is a flow. Why high current is a flow? Because our side is a low, fixed voltage. Low current is vary with respect to the load only. I is totally depend with respect to the load only. Current is a vary with respect to the load only. When load is increased, current is increased. So it's a directly proportional. Okay, if the load value is less, the current is less. If load value is increased, current is increased. So this first customer, they didn't use it. Full current is a flow. The bulb, it is not distant. They will going to get a failure. That's why if the power supply, it's a AC power supply, for example, in condition lamp. So in that in condition lamp, connected series with one choke. Choke means a tube light available choke. That is called a inductance. Tube light, electrical tube light. That tube light, it is because nowadays electronics and then LED tube light is coming. The electrical tube light choke used to, you going to save the bulb. That's all. This is a di by dt. Okay, the flow of the high current you will going to minimize. I hope you are understanding here. Then let's we move to that dv by dt. High voltage is flow. Sudden for example, transmission line also, what will happen? Okay, in the substation, it is a some changes of the voltage, it will going to flow. Sudden that voltage fluctuation, voltage low voltage, high voltage. Sometimes you may know that one your lamp and then fan fan is rotate, even the your speed is a 5, your fan is rotated on the very less RPM, very dead RPM. Why means a low voltage. The voltage is a very low. Your tube light also, if you have see that one, it is a glowing very less illuminations. Okay, so that is a low voltage, high voltage. High voltage you are going to apply it, you are going to fail. So that's why here is the resistance and capacitance is connected across to the device to save the device from the dV by dt problems. That is called a snubber circuit. Okay, next one is a GTO. GTO is as similar to that one SCR. Okay, only one thing you want to know here is a gate side is a two arrow mark. It is represented. It's a control turn on and as well as control turn off. That's all. Control turn on and the control turn off. As similar to that PN junction only. So as usual for P for the anode time. Okay, N for the cathode and P for the gate terminal. As similar about that one. Two transistor analogy. They will going to connect it to constructed about that one as similar to about that and developed about the GTO. That's all. So GTO, when you have look about that one, only one comparison if you want to look at. So GTO, SCR versus the GTO. SCR is a high power device compared to the GTO. It is high power device. On state voltage drop across to that device is it's a very less on state voltage drop, but it is a more. And then turn on time is this is you have see 8 microseconds. It is needed for 2 microseconds. It is needed for the current is a 200 milliampere. It is higher amps is needed. Higher amps is needed for the turn on. And then frequency wise, it is a 100 hertz only. It is a 10 times. 10 times it's a higher fast frequency. So 1 kilohertz. Okay, turn off the time. So turn off the time is 150 microsecond. It will go to fast because it's a control turn off. Here is a commutation technique used to. You will going to turn off. It is taking more time. It is a very less. That's all about the difference between the SCR and the GTU. So we are discussing about rating of that one. Which one is rating? High rating is SCR. Low rating for that one. Compare with that one GTU. Class C and Class D is the auxiliary device. It is used to turn off the SCR. So GTO is better than SCR. Yes, it is better than SCR. Why it is better than SCR? Because the first switching frequency is very high, 10 times is high. That's why it is better. And the turn on time is see that one turn on time as well as turn off time is very fast compared to the SCR. Compared to the SCR, it is very fast. But voltage drop is more as well as consumption of the current is needed for that one is high. So that is about that one. Yeah, dynamic characteristics nothing but it is animals. So animal diagram just you will going to remember. So how same method you will going to start to explain. Static characteristics nothing but you will go to testing. So testing the SCR. Okay, you will going to give the triggering circuit and the power circuit. You will going to find the testings. That's all.